Welcome to this video. So today we are going to discuss the standard normal distribution. We're going to discuss what it is, what it means, and how we can use it to solve questions. Okay, so to start with, we're going to define it. So what exactly is a normal distribution function? Okay, so the normal distribution function is simply a type of continuous probability distribution that is symmetric about the mean and as a bell-shaped. So if we draw it, it's something like this. And then you have a smooth curve like that. Okay, so it is symmetric about the mean, meaning that when you cut it into two parts like that, here you're going to have the mean, and then the part that you're going to have this side, okay, will be equal to the part that you're going to have that side. That's what we say, that's what we mean when we say that it's symmetric about the what? The mean. Okay, so this standard normal distribution, it's usually represented by Z. Okay, so they will say Z follows a normal distribution with two important parameters. The first one will be the mean, and then the second one will be what? The standard deviation. So this symbol here represents the standard deviation. This one here represents the mean. Okay, so in most cases, when we are asked questions about the standard normal distribution, we'll just be finding the probability that Z is less than a certain value or Z is greater than a certain value. Okay, so for example, if this is my minus Z here, and then this one is my plus Z here. So you can be asked to find the probability, okay, that this Z is less than this minus Z here. So it means you concentrate only on this probability that I've shaded in what? In blue. And then you can also be asked to find the probability here, which is greater than the Z there. Okay, so it means you only focus on the probability that is this side. Okay, but the most important thing is to know that the total probability, okay, under this bell-shaped curve here, okay, the total probability there will always be equals to what? 1. Okay, so if you know the probability of this part that I've shaded in green here all the way up to there, it means you can just say 1, okay, minus this probability here. I mean, you can say 1 minus this probability in green here to get the probability that I've shaded in what? In blue there. Okay, so that's what we are going to be doing on most of these questions that are involving the Z-score. Right, so this Z-score here, it's a special random variable because any random variable that you are given, it can be converted to a Z-score. Okay, so how do you convert any random variable to a Z-score? You use the formula Z is equals to X minus the mean and then divided by the what? The standard deviation. So this here will be the formula that we are going to be using to convert any random variable that we can be given to the what? To the Z-score. And then once we have the Z-score, we can use it to find the probability. So how do we find the probability? We use what we call as the Z-table. Okay, so the Z-table is just simply a systematic table that you can use to find probabilities. So it's in this form. So you're going to have columns and rows like this. Okay, so for example, here I can have maybe 0.2. Okay, so here I'll put the Z-score like that, and then here I can have 0.1. Okay, so you can be asked to find the probability that Z is less than 0.3. So for you to find the probability that Z is less than 0.3 here, you go to your Z table, okay? You find two numbers, okay? One, it should be from the columns, okay? And then the other one should be from the rows. So such that when you add them, they give you the value of the Z that you have there. So as you can see here, here I have 0.2, here I have 0.1. So when I add them, they give me what? 0.3. So it means the probability that this Z here is less than 0.3 will just be where this value and this value are intersecting. So you go in this way, and then there you are coming down in the south direction there. Okay, so where they meet here, that's the probability that you are going to be getting from the z-score table. Okay, and then sometimes they can ask you to find the z-score itself and not the probability. Okay, so what do? You first of all identify the probability that you've been given. So maybe the probability is 0.2271, something like that. So maybe it's here, 0.2271. And then they're asking you to find the z-score that will give us this probability. Okay, so it means you go to the far end here, you get the value in the column. Okay, and then you even go to the far end this side again, you get the value that will be in this column. So you add this value to this value to get the z-score that will give you a probability of that magnitude there. Okay, so let's try to solve this question here so that we can deepen our understanding. Okay, so here they're saying the random variable x has a normal distribution with the mean 30. So it means the mean there is 30 and standard deviation 5. So it means the standard deviation there is 5. Okay, so A, find the probability that this x is less than 39. Okay, so the first thing that we have to do is we have to standardize, okay, the random variable x that we've been given there. Okay, so we can standardize this x and this 39. So I'm going to say probability. So how do I standardize this x? I just write it in this form. So I'm going to say x minus the mean, then divided by what? The standard deviation less than. I have 39 minus. Okay, so what is the mean? The mean is 30. So I'm going to put 30 there, and then divided by the standard deviation, which is what? 5. So this is what I have. So x minus mu, or minus the mean, and then divided by the standard deviation. This is not 6, this is standard deviation. It's just the same as z. So this is the probability of z being less than, okay? So we're going to say 39. All right, so here we're going to have 39 minus 30 divided by 5. So that is 9 over 5. Okay, so it means we are going to have the probability that z is less than 9 divided by 5, we're going to get 1.8, I mean. Okay, so it means here we are simply finding the probability that this z is less than 1.8. Okay, so how can we find this probability? We go to the z table, okay, or the z-score table. So z-score table, okay, I have it here. So we want the probability that z is less than 1.8. Okay, so you are going to come to your column parts here. You're going to pick okay, we're going to pick 1.8. So 1.8 is here. This is 1.8, and then it means on the row part here we're just going to pick 0, 0 or 0, 0 there, so that when you add 1.8 plus 0.00, you still get your 1.8. So want the probability that z is less than this 1.8. Okay, so it means you can come down from this row here, and then from this column you can go to the left like this. So the intersection will happen here. So it means that will be the probability that we are looking for. So this one here will just be 0.9641 if we round off to 4 significant figures. Okay, so we are done with the first one. Let's look at the second one. So on the second one, we're doing the opposite. So on the first one, we are finding the probability given a certain z-score, and then on B here, okay, we're given the probability, and then we want to find the z-score. So first of all, let's standardize what we have. So we have x less than d. Okay, so it will be the probability of x minus mu divided by the standard deviation less than d minus the mean, which is 30, over the standard deviation, which is 5. Okay, so this here they're saying it's giving us what? 0.1151. Okay, so this is the same as the probability of z being less than d minus 30 divided by 5. Okay, so here we've been given the probability. Okay, the probability has been given as 0.1151. So we want to find the z-score that can give us this probability here. Okay, so once we find that z-score that can give us this probability, we're going to equate it to this guy, and then we're going to solve for d. Okay, so you go to your z-score table, you look for a probability of this magnitude here. So if you notice here on this my first z-score table here, there's no value here which is less than 0.5. okay, they are all starting at the lowest is 0.5 here, and then the highest is 0.999 up to 7. So it means the positive z-score table okay won't help us in this case, so we have to go to the negative one. So this is the negative one here. So now let's look for that value. Now what was that value? 0.115v1. okay, so 1151, where is it here? So you check on all these probabilities here. So it can be tricky, but just be patient, you're going to find it. So in this case I've found it there. So this value that I'm putting in a box here, so this is 0.1111 I mean 0.11507. so it means when we round it off we're going to get 0.1151. so this is what we are looking for. So to get the z-score, we're going to go up here. Okay, we are going to get 0.00, and then if you go this side we are going to get minus 1.2. okay, so it is minus 1.2 plus 00. That will be the z-score. Okay, so we see that this is 0, 0, 0, so it won't affect this one, so it remains the same. So when I come back here, I'm going to say, okay, the z-score that gives us this probability is minus 1.2. so this 1.2, I'm going to equate it to whatever I have there. So we're going to say d minus 30 divided by 5 is equals to minus 1.2. And then let's solve for d. Okay, let's solve for d. So from there it means our d, okay, to be d minus 30, and then we can multiply 5 and the minus the minus 1.2, we're going to get minus 6. So it means d is equals to 30 minus 6, so d is equals to 24. Okay, so found the value of d, we can write it here. So d is simply 24. And then now let's find the other one here, which is question C. Okay, so question C, they're saying the probability that x is greater than e is equals to 0.1151, the same number. Okay, but here now notice that the sign has changed. Okay, the sign has changed. Here it was less than d, here it's greater than d, but they're giving us the same probability. So how? So remember in the definition we said this normal distribution is symmetric about the mean, like that. Okay, so if this is the mean, we said the part that we have this side is equal to the part that we have this side, right? Okay, so meaning that if I have a certain number here, okay, if I have a certain number, maybe there, maybe I'd say that the number is p, and then there it's q, and this q and p are from the same distance, like they are from the same distance from this mean here. So it means that their probability, if I go up like that, okay, the probability that I'll have there for z is less than p, and the probability that I'll have for z is greater than p, greater than q, I mean, they're going to be the same. Okay, so in other words, if the probability is the same on the right hand side there, okay, it means we have to apply the symmetry of the normal distribution. Okay, we have to apply the symmetry of a normal distribution. So it means here, this guy here, we can change it to a guy that will have a less than, okay, just like this one here, the one that we did there. So we can say this one here is the same as the probability, okay. I should say it's the same as 1 minus the probability that this x is less than e, okay, and then is equals to 0.1151. Okay, so we can take this one to the other side and then bring the one to the other side. So it will be 1 minus 0.1151 is equals to probability that okay, it goes to the probability that x is less than what? Is less than e. Okay, so this is what we have, and then from there we can subtract here. Okay, so let's subtract. Okay, so we have 1 minus 0.1151. So I'm going to get this side, I'm going to get 0.8849, and then this is equals to the probability that x is less than e. So now we can use this to find the value of e. Okay, so let's say this. So we're going to say the probability of x less than e is equals to 0.8849. So now I want to find the value of this e. So first of all, we need to standardize. So when you standardize the x, okay, it's just going to become the z is less than, this one will be e minus 30 divided by 5 is equals to, and then this probability. So which z score gives us this probability? Okay, so you got your z score table. So this is 0.8849. okay, so 0.8849, we have to find it on the positive z score table. Okay, so 0.88 and then 49. So 8849, we're going to find it there. Okay, so if I go up, this is 0.00, and then if I go this side, this is 2.1. So I'm going to add those two, 2.1, I mean 1.2 here. So 1.2 plus 0.00, so we're going to get 1.20 like this. So it means the z score there for the this whole thing here is just what? 1.2. So we can equate this whole thing to this and then solve for the value of what? E. So we're going to say e minus 30 over 5 is equals to 1.2. So this will be e minus 30 is equals to 1.2 multiplied by 5. I'm going to get 6. Then e will be equals to to be 30 plus 6. So it means e will be equals to what? 36. Okay, so we found our e to be 36, our d to be 24. Okay, so now we are ready to find the last question here. Okay, so the last question, they're saying find the probability that d, okay, less than x less than e. Okay, so now we know the values of d and e, so this will be the probability of 24 less than x, which is less than 36. So we need to standardize this. Okay, so it will be p 24 minus 30 divided by 5 less than, if I standardize the x to just give me this, so that will be a z greater than less than 36 minus 30, which is 5, of which we're just going to end up with what we had. So this one here is going to give me minus 1.2 less than z, this one here to be 1.2 like this. So I'm finding the probability that z is between minus 1.2, okay, and 1.2. Okay, so now we have probability of minus 1.2 being less than z being less than 1.2. Okay, so this is a negative here. So this one here is the same as 1 minus 2 probability of z being less than 1.2. Okay, so this here will be 1 minus 2, and then the probability that z is less than 1.2, we already found it was there. Okay, because this d here we found it was 24, and then when you standardized it, it gave us 1.2. So the probability that x is less than 1.2 is good. It's there already. So we're just going to put 0.1151. So this one, when we punch in on the calculator, I'm getting 0.768. Okay, the 9 comes first, so 0.7698. Okay, so this one here will be the probability that x is between d and what? And e. Right, so that's all for this video. If you'd like to access the full video where I'll be solving all the questions in this tutorial sheet, you can check the link in the description below.